so we're going to kind of do this one section 4.4 by itself. It doesn't really build on anything after this. So this is kind of a separate section, and I usually do this section because on the test, this is an easy section. Okay? And it balances out the harder sections for the rest of the week. Okay, so that way on the test, the grades aren't usually as bad if I put a lot of this stuff on it because it's much, much easier. So that's usually why I balance it with this. Okay, so you guys don't see this till the final. All right, so there's a triangle. Okay, and I've labeled some things in it, not everything. But B is the base. Okay, that's the length of the bottom.
Wait, so was that equation you just showed? Like
the law of cosines? I'll tell you when that's going to come up. Okay. H is not hypotenuse there. H stands for the height of that triangle, the dotted line. A is the length of the upper left side. And gamma is the angle between the base and the upper left side. Okay, I didn't label any of the other angles or the other side because I'm not going to use it here. All right, so if I wanted to find the area of that triangle, what's the formula? Matt, I think you said it earlier. Yeah, the area is 1/2 the base times the height. Now, that formula works perfect as long as you know the base and the height. Okay, all you have to do is plug them in. Take 1/2 times the base times the height, and there's your answer. Now remember, it's area, so when you write your answer, it should be like square units. If they tell you the units, you could do like square inches or square feet. If they don't, just put square units. Okay, the problem with that formula is if you have a triangle where you don't know the height. Okay, like, let's say you had a triangle like this. This side is 8, this side is 5, and this side is 6. You don't know the height there. Okay, the height would be like if this is the ground, and you were standing right here, and you drop something straight down. That's the height. Okay, you don't know it. Okay, all you know is the sides. Or they could give you something like, maybe instead of that side, they tell you this angle is 120 degrees. Okay, so they switched out a piece of information, but you still don't know the height. Right? So, if you don't know the height, then we're going to have to use something a little different. But it's still going to be based on 1/2 the base times the height. So I'm going to use this diagram that I have up above. Okay. Okay, what I want to do in that diagram is find a formula for the height. Right? Let's pretend like they gave you 3 things. 1, 2. Yeah, actually, they give you 2 things. As long as they gave you alpha and gamma, you could find H. Right, so as long as they gave you the 2 things on the left I circled, you could find the 3rd thing. So, for now, just look at this. Forget about that other side of the triangle. What kind of triangle did I just make in red? It's a right triangle. Anytime we have a right triangle, you can use the Sokotoa stuff. Opposite, adjacent, hypotenuse. So, look at the 3 things I've circled. 1, 2, 3. If you were standing at gamma, what's the name of the side that's farthest away? Opposite. And what's the name of the side that's across from the 90-degree angle? Hypotenuse. Opposite is the side furthest away. A is the hypotenuse. Which trig function has opposite and hypotenuse in it? Sine. Yep. So, I'm going to write an equation that's going to allow me to figure out the height if I don't know it. It's not using anything new. It's just using the right triangle stuff we did a couple weeks ago. So, sine of your angle. And how do you pronounce that one again?
Gamma.
Yep, sine of gamma equals opposite over hypotenuse. So h over a. So my goal is to get h by itself so that I have a formula for it, so I can find it if I need it. Okay, so how would I get this a on the other side? Yeah, multiply it. Yeah, multiply each side by a. That's gone. And there's your formula for the height. A sine gamma. Right, so what we're going to do now is basically substitution. This is the old formula for area of a triangle. 1/2 base times height. Instead of h, I want you to put, bless you, what's in that box. Because we just came up with a formula for h. All right, so let's plug in that for h, because that's what it's equal to. If you do that, that's what you get. You still have the 1/2, you still have the b. We didn't change those. The only thing we changed was h. Instead of h, I put a sine gamma. Now, this is all multiplied together. 1/2 times b times a times sine. When you multiply, does it matter what order you multiply in? Like 2 times 3 times 4, 4 times 3 times 2, same thing? What do you think, Cal?
Yeah, it does matter.
So, if you did, like, just use the example I said, what's 2 times 3 times 4?
That's 24.
2 times 3 is 6, 6 times 4 is 24. Now, what's 4 times 3?
Well,
Times 2?
24.
So, does it matter?
No.
No. The order you multiply in doesn't matter. So, what we're going to do is we're going to write the formula that way. Instead of 1/2 BA sine, we're going to write 1/2 AB. The only reason for that is just so it's in alphabetical order. But that doesn't matter. So there's a new formula for the area of a triangle. If you don't know the height. What it does depend on is that now you know two sides and you know an angle. Let me draw a triangle. You can't just know any angle. Let's look at where gamma would be. Look at where this is in relation to those two. Here's A, B, C, alpha, beta, gamma. Looking at that diagram, or any diagram that you draw that I've shown you this year, where is gamma compared to sides A and B?
Across from C.
Well, it's across from C, but how about compared to A and B?
Between them.
Between them. And that's the whole key. You can know any two sides. These are all the same formula. You can have any two sides you want as long as you have the angle between them. That's the key. You have to have the one between. So look at the next formula. 1/2 the product of two sides, this time B and C. What's the angle between sides B and C? Alpha. Yep. And the last version, still 1/2 the product of two sides, except now the two sides you're given are A and C. What's the angle where A and C meet?
Beta.
Beta. Yep. It's all the same formula. So what I would do, rather than trying to memorize 3 different versions of the formula, memorize the idea behind each one. 1/2 the product of two sides times the sine of the angle between them. And the idea is more important because I may give you a problem where none of the sides are labeled. I'll come right back to that. But, like here, which side's A, which side's B, which side's C? Any side you want. So it's not like you can really use a specific version of the formula here. What you use there is that idea. 1/2 the product of the two sides that you're given times the sine of the angle between the sides. Okay, and you'll always be given the angle between the sides. You're not going to be given the angle that's somewhere else. Okay, so what's kind of nice about everything we do today, it's all calculations. It's all use a calculator, you type it in, you get a number for an answer. It's very, very concrete. The rest of the week is not. Okay, it's more abstract. But any questions on that idea? 1/2 the product of the two sides times the sine of the angle between. So we're going to learn two formulas for the area of a triangle today. I proved to you where this first one came from. Okay, we kind of went through it. The second one, we don't prove where it comes from. Out of those two formulas, you definitely will only see one on the final. Okay? Because the final has enough material on it that I can't really ask you more than one question from each section. It would be too much. So we're going to learn two formulas today, but you're only going to have to know one for the final. Okay, so let's take a look at that. Now, whether they give you a problem like that or whether they give you a diagram, doesn't matter. It's the same type of information. Okay. Anyone think they can set up my equation that I'm then just going to type into the calculator to get the area of this triangle? Yeah.
1/2 8 times 6 sine 30.
That's it. Nowhere in there did they give you the height of it. If they said the height was 2, then all you would have had to do was 1/2 base times height. But since they didn't, you're using the formula I just showed you. 1/2 the product of the two sides times the sine of the angle between them. And a lot of it you can do without a calculator. 1/2 of 8 is 4. 4 times 6 is 24. And now let's type that in. But as always, what do I want to double check first before I press any buttons? Make sure I'm in degrees. Okay. You can do this in radians. I think all of the problems I give you though are in degrees. Okay, so I'm in radians, so I'm going to switch to degrees and type in 24 sine 30. So if you remember from unit circle trig, the sine of 30 is 1/2. 0.5. So really, this is 24 times 1/2, or 12. Okay. Most of the time, the answer is not going to come out nice if you just pick a random angle. Like if you made this angle 31, I'd have to use a calculator to get the answer. But since it was 30, technically I could do that one without. Okay. So the area is 12, and what do I want to make sure I put on it? Yeah, units is in 1D or 2D? 2D, right? That's area. So you're just going to put 12 square units. If it was inches, I would have put inches, but I don't know what it is. Okay, I'll give a label on the next one. Okay. Any questions on that? What's that? Like I said, most of these are going to come out to decimals, though. Okay, let's look at this one. Okay, so what's different here? I already told you guys. You don't know which side is which. Doesn't matter. As long as you understand that, you've got enough information in the diagram I just gave you to do that. All right. So let's set up the formula for our area. Okay, how about someone besides Andrew this time? Can someone tell me what my formula is going to be?
Half.
Yeah.
And then 4 times 3.
So So 1/2 the product of the two sides. Yep.
And sine theta.
Yep. Now, again, we just did sine 30. It's not always going to be 30. It could be different angles. But since it's 30, we should be able to do this one without a calculator. So, Courtney, 1/2 of 4 gives me 2 times 3. 6. And Alyssa, what did we just get when we did sine of 30?
Half of the number.
So it's half of the number in front, so 1/2 of 6 gives me 3. And this time I have a label of inches. So what's going to be my final answer?
3 inches squared.
3 inches squared. Okay. That's it. It's very, very, very simple. Very different from what we're going to do the rest of the week. Just plug into a formula. Okay. Any questions up now? Okay. Let's look at this one. So we're going to use the same formula again. But what's different? There's no angle. Well, that's a problem. Okay? In order to use that formula I gave you, you only got two options. You could go back to the basic formula from geometry, 1/2 base times height. Problem is you don't know the height. 5 is not the height. Height has to be straight up and down. That's not straight up and down. Okay? I could say that the base is 4, yes, but I don't know the height. So we got to use that formula, but we're missing an angle. I got to find an angle. Doesn't matter which one. Any one you want. Does anyone remember the name of the formula that we did maybe a couple weeks ago? That if you know all the sides in a triangle, you can find the angle. Law of cosines. Yep. So we've got to do the law of cosines one time just to find one angle. Not all of them, it's just one. And then we can use the formula. All right, so this one would be alpha, beta, gamma. All right, so Abby, which angle do you want to try to find?
Beta.
Beta. All right. So, remember, that's what the law of cosines looks like. That's not the angle she told me to find, though. She wants to do beta. That's fine. We just have to change the letters a little bit. Beta starts with b squared, and it ends with beta. Right? So the idea is one side squared equals the sum of the other two, minus twice the other two, and then the cosine of beta will go at the end. All right. So what I'm going to do is I'm going to write it. I'm going to write the formula first so I don't have to try to remember it and plug into it at the same time. So one side squared equals the sum of the other two minus twice the other two that I just wrote, cosine of the angle across from the letter I started with. Okay, so what's nice here is A, B, and C, there's no decimals. We're probably going to get decimals in the final answer eventually, but not at first. All right, so let's go through it. Justin, let's start with b squared. What's b squared?
8, or 16.
Yeah, 16. Equals, and Megan, what's a squared?
I thought you said 8. Never mind.
Oh, a squared, not a squared.
Oh, yeah, well, yeah, what is a squared, which is 8 squared? 64. Plus c squared. How about, Stephen, what's c squared?
25.
25. Minus 2 times a times c. All right, let's see if we can do that. 2 times 8 is 16. And 16 times 5. What's that going to give me? 80. Cosine beta. Okay, so our goal is to combine all those like terms together and get our answer for beta. What could I do first on the right?
64.
Yep, I can add 64 and 25. What's 64 plus 25? 89. Now remember, you can't do 89 minus 80. Okay, this equation is basically like this one. The 80 is multiplied by something you don't know. Those aren't like terms. So, what do I have to do with the 89? Subtract it to the other side. So minus it, that's gone. Minus it there. Let's see what we get. 16 minus 89, negative 73. Now I've got 2 steps left, and then I'll know my angle. What's my second to last step? Divide by negative 80. Yep. When you divide by negative 80, that's gone. That's gone. That's gone. Okay. Remember, always good that the bigger number ends up in the bottom. Okay. If the bigger number isn't in the bottom when you go to do an inverse, it's not going to work. Okay. So, basically, I just told you the last step. How do you get rid of regular cosine?
Inverse.
Inverse. So take the inverse cosine. That's gone. Inverse cosine. And now we're going to get our angle. And once we have it, then the area is easy to find. Probably not going to come up to a nice number. So it's inverse cosine of 73 over 80. Again, make sure you're still in degrees. Okay, so the angle is 24.15. Now, it doesn't matter which angle you find. It's not like doing one of them might be more or less work. It's going to be exactly the same. Good. Now I can find the area. If I'm using beta, which I am, because it's the only angle that I know, what are the 2 sides that I'm going to use out of the 8, the 5, and the 4? Yes. So it's 1/2 the product of the 2 sides. We could have done that right away. That wasn't a problem. The next part was the problem. Times the sine of the angle between them. Okay? We didn't know it. Now we do. So 1/2 the product of the 2 sides times the sine of the angle between them. Madison, what's half of 8?
4.
And then 4 times 5?
20.
So it's 20 times the sine of 24.15. 20 sine 24.15. So the area is 8.18 square feet. So a little bit of extra work because we had to find one of the angles. It's a lot easier if they give you the angle up front. Okay. But if they don't, that's how you can do it. Notice I didn't say that's how you have to do it. Everything we did there was fine. It worked. But there's a much better way to find the area if they give you all the sides than what we just did. That's not the best way. But keep that number in mind, 8.18. So a much easier way to find the area, if you know all the sides, is to use what's called Heron's formula. It's basically a way to get around having to find the angle. And the proof of Heron's formula, which we don't go through, would involve this, the law of cosines. So Heron's formula is based on using this. It's kind of built into the formula for you. So let's look at what Heron's formula is. That's the formula. And we're going to try it and see on the last problem if we get exactly the same answer doing it this way and doing it the way we did it. So it says that the formula is the square root of s times s minus every side. S minus a, s minus b, s minus c. Okay, so you got to do s minus every side. So we know a, b, and c are the sides. What about s? Anyone have a guess what that is? It's not obvious. What do you call the distance around the edge if you add it all up?
Perimeter.
It's the perimeter. Well, S is called the semi-perimeter. Basically, that just means half the perimeter. So if you add up all the sides and then take half of it, that's called the semi-perimeter. So it's the square root of the semi-perimeter times the semi-perimeter minus every side, each one of those separate. S minus A, S minus B, S minus C. So if I had to find the area of a triangle and I just knew the sides, I would probably go for this first, rather than doing all the stuff we just did on the last problem. But if you forget this, you don't need it. You can do the problem without this formula. We just did. Okay? But this is a shortcut if you've got room like on a reference sheet and you want to use it. Okay, does everyone have the Heron's formula? Okay, so now, 4, 5, so I want to do the same problem we just did. So we had sides of 4, 5, and 8. So let's do the same problem, 4, 5, 8. Okay, we already know the answer. What did the answer come out to the last problem? 8.18. Okay. So keep that number in mind. Now let's see if that's what we got. Okay, doesn't matter which side is A, which side is B, and which side is C. At all. You just have to do S minus every side. But we do have to find S first. Okay, that's the semi-perimeter. Okay, what's the perimeter here?
All sides added up.
Yep,
7.
17. So what's half of 17?
8.5.
8.5. So that's your semi-perimeter. Right, now let's set up our formula. Okay, what's the first thing that I do under the square root? So looking back at that formula, what's the first thing that's under the square root? You put the semi-perimeter, which in our case is how much? 8.5. And then we have to do the semi-perimeter minus each side. So you can, if you want to do it in your head, you can. I'll write it out the first time. But it's 8.5 minus 8, 8.5 minus 5, 8.5 minus 4. Now, before I type it in, what I would do is just simplify all the subtractions and then type everything in. All right. So we're going to have 4 things. 8.5. What's 8.5 minus 8? A half. Okay. What's 8.5 minus 5? 3.5. And 8.5 minus 4. 4.5. Now, type all that in, and as long as we've done everything correct, we already know we should get 8.18 for the area. And we avoided having to do law of cosines. Yes, it is another formula you have to remember, but it makes it so then you don't have to remember law of cosines. Okay, let's see what we got. Square root of, on my calculator, I'm just going to use the times button. I could use parentheses, but this is less typing. 3.5 times 4.5. And the area comes out to 8.18, which is exactly the same area that we got before. Well, it's not exactly the same. It's close. Why is there a little bit of a difference? Yeah?
Because we rounded in the first one.
Yeah, we rounded. Remember the angle, 24.15? We use law of cosines and we rounded that off. All right? But you can see they're basically the same thing. So there's your area. Okay. Any questions on that one? All right. So now you can come up with special formulas for every kind of triangle, right? You've got a formula, you could come up with a formula to find the area of an isosceles triangle. You could come up with a formula for anything. We're going to come up with one more. So I want to see if we can get a formula for the area of an equilateral triangle. Now, you already have two formulas that you could use. You could use Heron's formula. You could use the first formula I gave you. How come? What are all the angles in an equilateral triangle?
The same.
And they're all what number?
60.
They're all 60. So technically, if you're saying, well, you don't know any angles, if it's equilateral, yes, you do. They're all 60. So you could go back and use the first formula without even having to use anything tricky, right? You already know the angle is 60. But there is an even easier way. So if it's equilateral, we know all the angles are the same. What else is the same?
The side.
All the sides. So I'm just going to call it x, x, and x. Okay, I don't know what the sides are. But whatever they are, they're all the same. Pick a letter and use that letter 3 times. What's the perimeter of that triangle?
Cube. 3x.
3x. It's x plus x plus x. So the perimeter is 3x. So what's the semi-perimeter? 1.5x. Okay, so there's your semi-perimeter, 1.5x. Now let's plug that into Heron's formula. We're going to simplify it, and we're going to get something pretty simple for the area of an equilateral triangle. And then we'll use it on this problem. Emily, in Heron's formula, what's the first thing we write down, and everything is going to go under this?
Square root.
Yeah, put the square root. And Grace, what's going to be the first thing under the square root?
The 1.5 or the semi-perimeter.
Yep, the semi-perimeter. And then it's s minus every side. So now we're going to write that. And this is where Heron's formula gets annoying, because why are we writing the same thing 3 times? There's got to be a faster way, right? But we'll see what that is in a second. So semi-perimeter minus the first side. Semi-perimeter minus the second side. Semi-perimeter minus the third side. So each time we do that, the first one's going to stay the same. But what's 1.5x minus x?
1.5.
How much?
1.5.
Well, so it's like 1.5x minus 1x.
So,
Half x. Yeah, we can write it half. You could write 0.5. Either way, you know what? I'll do it as a fraction. But if we're going to do it as fractions, we should do everything as fractions. And actually, the fraction might be easier, but 3 over 2 is 1.5. Half x, half x, half x. Now, under that square root, I have 8 things, all being multiplied together. 1.5 times x times 0.5 times x times 0.5 times x times 0.5 times x. Does the order that you multiply in matter? No. Then what I would rather do is, rather than staggering it number, letter, all the way through, let's put all 4 numbers right next to each other, and then all 4 letters. And that'll make it look, I think, a little simpler. 3 over 2 times 1 over 2 times 1 over 2 times 1 over 2 times x times x times x times x. It's exactly the same thing, we just change the order. Okay, so let's multiply those fractions right across. What's 3 times 1 times 1 times 1? 3. And 2 times 2 times 2 times 2? 16. So 3/16. And what about x times x times x times x? What's a shorter way to write that?
4.
Careful, that would be if you were adding them. Yep.
X to the power of 4.
Yep. Okay. So now we're getting something pretty simple, right, for the formula of an equilateral triangle. The last step is just take the square root. Now, you have to take the square root of a fraction. You take the square root of the top and the bottom separate. And then you also have to take the square root of x to the 4th. You've got to take the square root of all 3 of those things. So it's this over this times that. Now the square root of 3, we can't really do anything with it. How about the square root of 16? Yep, 4. And the square root of x to the 4th. So think what 2 things you can multiply together that are the same, that give you x to the 4th. X squared. Yes. X squared times x squared is x to the 4th. And that is the formula for the area of an equilateral triangle. Square root of 3 over 4, x squared. Now, do you need that formula? No. You don't need that formula at all. You could use Heron's formula. The reason I don't like Heron's formula is because I have to do the same thing 3 times in a row. If I have to keep doing the same thing 3 times, there's got to be a faster way. That's the faster way. Only thing you have to tell me is x, which is the length of the sides. That's the only number you need. One number in the whole formula. Okay, everyone have that formula? Okay. So, if that was a question on the final, find the area of the equilateral triangle, you can do it any way you want. If you're running out of time, you don't want to guess.
Please excuse the interruption. Any student who did not receive...
Okay, so if you were running out of time on a test and you're like, you know what, I got to get the answer, I don't have enough time to go through Heron's formula, use the shortcut that I just gave you. So, Pat, can you remind me, what's that formula that we just came up with? Just hit enter. Square root of 3, yep.
3 fourths
Yep.
times x squared.
Times x squared. Now, in this case, x is the length of the side. So, what's the length of the side I'm plugging in? Oh, no.
What was that?
What's the length of the side I gotta plug in?
8.
8. So just fill in 8. Now, we'll probably need a calculator, but I think most of it we can get out of the way without a calculator. 8 squared. Maddie, what's 8 squared?
64.
64. So I've got square root of 3 times 64 divided by 4. So I think all we can do without a calculator is reduce 64 over 4. Is that going to go in evenly? Let's check. 64 divided by 4. Yeah, 16. So square root of 3 times 16, and then just see what that comes out to. Let's see. 3 square root times 16. Okay, so about 27.71. Now, do I know what my length was measured in?
No.
No, so I'm just going to put square units. Okay, if you don't like that, use Heron's formula. You can get the same answer. It's going to take you longer, but you'll get it. If you don't like that, you can use the original formula. 1/2 the product of the two sides times the sine of the angle between them. But what you'd have to remember there is I didn't tell you any of the angles. You have to remember that equilateral triangle. They're all 60. So it's an extra thing you'd have to remember. Okay, this formula is probably the best. Yeah.
Why don't you have to divide the square root of 3 by 4?
Because when you multiply, it's just like if you had like 8 times 2 divided by 4, you don't divide the 8 by the 4 and the 2 by the 4. It's just one of them. Because it's just one factor in the top. So this is really just that. Let's try that. 8 divided by 4 is 2. Okay. Or if you just do it out the way it is, 8 times 2 is 16. 16 divided by 4 is 4. Yeah, but you don't divide both, just one. If it was addition, that's when you divide both. Okay. So now it would be 2 plus 1/2, or the answer would be 2.5. Okay. Okay, but yeah, good question. Hey, anything else on that? Okay, so that's pretty much what we're going to look at with area of a triangle. So last thing I'm going to do for about 2-3 minutes is just kind of show you what's going to come out. Bless you. Okay, for the rest of the week. Okay. In section 3.3, okay, and I'm not going to give you homework on trig identities tonight, but we're going to talk about what are called trig identities. That's what ID stands for, trig identities. Now, when we did unit circle trig, we had formulas for all of these. Sine was equal to a letter, cosine was equal to a letter, and tangent, we had 2 letters. Does anybody remember what letter sine was equal to? Yep, sine was y. And cosine was x. And how about tangent? It was y over x, perfect. Okay. Now, tangent is y over x. What did we just say that y was up above? Sine. What did we just say that x was? Cosine. So what that really means right there, that last line, is that tangent equals sine divided by cosine. What we did is we we took a formula that we already had, and we used it to figure out something else about trig functions. That's basically what trig identities are. Okay? So, let's say I did the tangent of 12. Well, according to my formula, that should be exactly the same as the sine divided by the cosine. And it is. Tangent is sine divided by cosine. That's a trig identity. And there's like maybe 7 or 8 more of those that we're going to look at. Okay. Somebody give me any number you want besides 12. Or 12 if you want. Doesn't matter. Give me another number.
26.
26. Watch what I'm going to do here. I'm going to take the sine of 26, and I'm going to square it. And I'm going to take the cosine of 26. And I'm going to square it. Watch what happens when I add them up. So there's the sine of 26 squared. Here's the cosine of 26 squared. Anyone know what's going to happen when I hit enter?
Would probably end up being a rather even number.
It's going to be a very nice number. 1. And it didn't matter what number you gave me. 26, 16, 12, 98, 22.4. It would have always come out to 1, no matter what. That is another trig identity. That if you take the sine of something and square it, the cosine of something and square it, it always adds up to 1. That never changes. All right? So those are the kind of things we're going to look at later in the week. All right, trig identities. So it'll be more stuff like this without numbers in it. We're not really going to do much with numbers, but numbers make it easy for me to show you why something like that works, because I can actually type it in on the calculator and you can see. So that's area of a triangle. We'll look at part 1 of trig identities tomorrow. We'll do part 2 on Friday. And then Monday, we'll do a review, probably just a review of the trig identities. Because I think you guys will be fine with the area of a triangle stuff. But we'll have to review 3.3. Okay, so homework tonight on page 280. 6 through 16, just the evens. 20, 22, and 33. And I'm giving you a hint for number 33. And number 33, they want the area of that little section in blue. The only way to get the area of that little section in blue is to get the area of that section in red, which is called a sector. It was one of the first formulas we learned in this class, first week of class. Find the area of that shape in red. Find the area of the triangle in green, which is what we did today. And then if you subtract the area in green from the area in red, you're going to be left with that little section in blue. So that's my hint for number 33. Okay, so you got about 25 minutes or so. I'll get the books out, so in case you need one, you can work on that. Or if you've got any other questions or anything else you want to check in with me about, now is a good time.